Hello students, welcome back. Hope you are doing good. So in this part, we'll be discussing about different concepts related to vapor pressure. We'll be discussing about two important laws, Henry's laws and Raoult's law. So let's start our session. Vapor pressure. So we'll be discussing about the important concepts related to vapor pressure. Vapor pressure. What is the vapor pressure? Let's understand in the slide the definition of the vapor pressure. So you can see this, there is a container, there is a solvent inside the container and there are some vapor molecules of this solvent present in this container. So this vapor molecules exert certain pressure on this solvent. So the pressure exerted by this vapor in the head space, this is the head space, is referred to the vapor pressure of the solvent. So vapor pressure is nothing but it is again the vapor, it is the pressure exerted by the vapor in the head space. Why head space? Because this head space occupies certain height, and if you multiply density into G, you will get the pressure exerted by this pressure inside the head space or in the head space. So remember, another important point is that every solvent in a closed container reaches a state of dynamic equilibrium. So in this figure you can see the dynamic equilibrium, that is which has been reached by the given solvent. Next important point. So the addition of a non-volatile solute, suppose this is a solvent and to this solvent you are adding a non-volatile solute. So if you are adding a non-volatile solute to the given solvent, it reduces the vapor pressure of the given solvent. For example, initially let's suppose this solvent has a vapor pressure P0, and because of addition of this non-volatile solute, the vapor pressure of the solvent reduces to P0 minus Ps. So this is the difference which occurs because of addition of a non-volatile solute. So the important point is, if you are adding a non-volatile solute to any solvent, it reduces the vapor pressure of the given solvent. So colligative properties. We'll discuss about colligative properties in our further part, but the important point you have to understand here that a non-volatile solute reduces the ability of the surface molecules or surface solvent molecules to escape the liquid. Right? We have seen that in the above figure. Because of addition of non-volatile solute, it reduces the ability of the surface solvent molecules, right? Remember, these surface solvent molecules only define the vapor pressure of the given solvent. So if its ability reduces, if ability to escape reduces, then automatically its vapor pressure is also lowered. So another important point, this is an important point. So the extent of this vapor pressure, so the extent which I call it as P minus Ps, depends on the amount of the solute. So this is directly proportional to the amount of solute which you are adding, to the given solvent. So there is an important law which quantifies the amount of vapor pressure lowering observed. So there is an important law which is Raoult's law. It quantifies the amount of vapor pressure lowering observed. So let's discuss what is Raoult's law. So Raoult's law gives an idea about the extent of the lowering of the vapor pressure. So the extent of vapor pressure lowering depends on the amount of solutes according to Raoult's law also. So Raoult's law quantifies the amount of vapor pressure lowering observed, which we have already discussed. So the important point is this, that the partial pressure of the solvent vapor above the solution, Pa is the partial pressure of the solvent above the solution, Xa is the mole fraction of the solvent. Mole fraction of the solvent, and P not E is nothing but it is the vapor pressure of the pure solvent. So the partial pressure of the vapor, of the solvent vapor, it is directly proportional to the mole fraction of the given solvent. Also, it also depends on the vapor pressure of the pure solvent. So the partial pressure of any solvent vapor, it depends on the mole fraction of the solvent, and also it depends on the vapor pressure of the pure solvent. So now Raoult's law gives you idea about what is the partial pressure of the given solvent and how it is depending on the mole fraction of the given solvent. It also gives you idea that P naught minus Ps and by P naught. So what is P naught? P naught is nothing but initial vapor pressure of the given solvent when you are not adding any solute, and P naught minus Ps is the final vapor pressure of the given vapor of the solvent after you are adding the given solute. So this ratio is called relative lowering of vapor pressure. Again I am defining it. P naught is the initial vapor pressure of the vapor, right, and Ps is the final vapor pressure of the vapor, right. Obviously P naught is not equal to Ps, right, P naught is not equal to Ps, right, because the vapor pressure is decreasing, and this difference is the lowering of the vapor pressure, and this ratio is the relative lowering of the vapor pressure. So we have already discussed that this value of relative lowering pressure, it is directly proportional to, this value is directly proportional to mole fraction of the solute. So there is another concept that relative lower pressure is always directly equal to the mole fraction of the given solute. So I can take P naught this side. So what I'll get? I'll get P naught minus Ps is equal to mole fraction Na plus Nb into P naught. P naught is what? Again it's the vapor pressure of the pure solvent. So this is very important formula which gives you the decrease in, this is the decrease in vapor pressure. So decrease in vapor pressure is nothing but it is equal to mole fraction multiplied by the vapor pressure of pure solvent, right. So now what happens if it is a dilute solution? If it is a dilute solution, remember guys, P naught minus Ps which is the decrease in vapor pressure, this is equal to Na by Nb, number of moles of A, number of moles of B into P naught. So Na can be Na plus Nb is nearly equal to Nb for a dilute solution. Remember this is for dilute solution. So these are few important concepts related to Raoult's law. Next move on to Henry's law. There is another law which is Henry's law, which also gives you idea about the solubility of a gas in a given liquid, right. Suppose we know that solute plus solvent gives rise to a solution. What happens if the solute is a gas, and what happens if the solvent is a liquid? So the gas should be soluble in this liquid, and the extent of solubility of gas in this liquid is given by the concept of Henry's law. So Henry's law states that solubility of a gas in a liquid is directly proportional to the partial pressure of gas which is in direct contact with the liquid. Mathematically, it is expressed as S is equal to Kh into P. What is S? S is the solubility of the gas. KH is the constant, which is Henry's law constant, and P is the partial pressure of the gas. So the solubility of the gas depends on the partial pressure of the gas, also Henry's law constant, and this Henry's law constant depends on the characteristic of the given solutions. So Henry's law gives you idea about the solubility of a gas in a liquid and the effect of partial pressure of the gas on solubility. Hi friends, so for any further doubts you can open askIITians.com and you can find the discussion board, and if you click on it you will get Ask Experts on the right side of the screen, and you select the category accordingly and you can post your question here. We experts at askIITians will be reverting you back within 24 to 48 hours. So students, this is what happens when you are adding a non-volatile solute to a given solvent. The vapor pressure of the given solution decreases. So we have seen these effects in terms of Henry's and Raoult's law. So in our next part, we will be discussing about different concepts related to an ideal solution and non-ideal solution. So till then, keep tuned to our sessions. Have a good day. Goodbye.